guys. Okay, well, I just got back from my walk, and now I am going to go over chapter 7, day 7, which is in your textbook. Day 7 had to do where we taught chapter 8. Sorry, guys. I'm going to teach chapter 8, section 2, page 208 to 212, one pager. Practice problems 210 and 213. I'm just going to do 210 today. 213 I might do later on tonight, or I might do it in the morning. And I'm definitely going to have Fridays up probably in the morning also, so you'll be able to come and watch on that, and we will be all caught up. So when we are talking about our ISM book, so right now I'm on page 99. Okay, I have gone through and I have put all my things in here. The only things that I haven't done yet is I haven't put them in my table of contents yet. So I still got to do that. If you're already finished with your book, that's fine. Start your new book. I'm going to start our new book on Monday. So that's where I'm going to be, because I want to kind of start all together maybe, because I know some people are still having a hard time getting online and stuff like that. So let's go ahead and let's dive into this and get this done today, and then we will continue this tomorrow. So what is this talking about? Is this talking about force at an angular velocity is where I'm at. So when we're talking about that, it was talking about a door. There's a reason why the door has have a knob. Sorry, let me move this up some for you can see it. Has a knob on the right hand side, and it actually has it where you're opening it out from a right angle. So if you look at the side view, and this is the top view, here's the brace that the door is on. This right here is the thing that attaches the door to the wall, and then of course these are the doorknobs, just in case you don't know my drawing. So when you are going through and you're trying to open the door, you're applying a force right here at this doorknob. This here is going to be what's called your lever arm, and this is going to be the axis of your rotation. These are important names for you to know. And then also it has beside, and this here, believe it or not, is a wrench. It doesn't look like one, but it actually shows you also when you're having a nut here and you're attached it. This right here is going to be your lever arm. This right here is going to be your radius. This right here is going to be your angle, okay? And then your radius, sine, angle. And this is important because we're getting ready to talk about it. Now, in the book, it talks about a lever arm. It said applied force. The change in angular velocity depends on the lever arm, perpendicular distance, axis on its rotation to the point where the force is exerted. So, what we have here is we have this equation, which is L, that's your lever arm, equals the radius, the distance from the axis of rotation to the point where the force is expended or applied, sine, and then the angle, and the angle is between the force and the radius. Okay? Torque, which is T, equals force times the radius, sine, the angle. So on page number 210, it gives us a practice problem. And on this practice problem, what it tells us is that a bolt of a car engine might be tightened with the torque of a 35 Newton per meter. Okay, so we're going to torque it that much. All right, and it says here you can use a 25 centimeter long wrench. Okay, and that's what we're doing there. And then you're going to pull at the end of the wrench at an angle of 90 degrees. So the torque, which is on the top, see, T is 35. R is your radius, which told us it was 0.25. Well, it told us 25 centimeters, and we changed it from 25 centimeters to 25 meters. And the angle is 60. Okay? So the first thing I want to talk about is the calculator. The first thing that you'll want to do is you will want to go to mode, and you would want to go back and change it into degrees and scientific, because we're going to be working with really small or really big numbers. So we're doing this equation right here. So to be able to do that, you're going to do alpha y inner. You're going to do 35 down, and that's 0.25, whoops, 0.25, and then I'm going to do my sine and 60 in close bracket. And if I hit enter, I get 1.6 in this whole long number, but in scientific notation, I get 1.6 times 10 to the second power, okay? So let's go ahead and let's look at our problems that we had to do. So number 11, consider a wrench in problem 1. So we're taking the information from the wrench in the example problem. What force is needed to apply to the wrench pointing perpendicular to the wrench? So the angle is perpendicular. When they say the word perpendicular, that's going to be a 90-degree angle, okay? So the only thing we're doing is we're doing the same thing we did before, except this time we're just changing the angle. And we'll get 1.4 times 10 to the second power. Question number 12. If a torque of 55 newtons per meter, okay, so 55 newtons per meter, that's our torque, right, is required to turn a bolt, and the largest force you can exert is 135 newtons. How long is the lever arm must be to turn the bolt? Well, we're turning it, so we're going to base that on a perpendicular again, and the only thing we're doing here is we're just taking our 55 and then dividing by 135 sine 90, and we'll get our answer, okay? Number 13, you have a 0.234 meter long wrench, okay? And so I changed mine. There's my radius, 0.234. The job requires a torque of 32.4 newtons. There's my torque. And you exerted a force of 232 newtons. What is the smallest angle with respect to the handle to the wrench at which you are pulling the wrench and getting the job done? So, this time we're changing it to sine -1. So let's go over how to do that. Your sine -1 is on the top of your sine button, and you have to use the blue for it, okay? So we're going to do our second sine, and if you notice on the calculator, you have sine -1, and then I'm going to do this next, alpha y enter. And so I'm going to do 32.4. I'm going to go down. I'm going to open my bracket, 232, close bracket, open bracket, 0.234, close bracket, and then I'm going to go over here and I'm going to hit enter. When I do, I get this scientific number. Well, this is not what I need to be able to find degrees, because that's what I'm trying to find. So I'm going to go to mode. I'm going to change it out of scientific. Okay? And then also, what I'm going to do is I'm going to hit second answer, enter again, and I get 36.64, and they rounded it to 36. If you rounded yours to 37, perfectly fine. So B, ask us for 13. A friend can exert 275 newtons. So this time they're going to do a force of 275 instead of 232. And the smallest angle she can use to accomplish the job. Well, let's see what we're doing here. We're doing our radius the same as we had before. The torque is the same this time. And now we're trying to find out what is the smallest angle. So we're going to do this sine -1 again. So I'm going to go over that. Second sine, okay? And then alpha y enter. And that is 32.4 down. And I'm going to do open 275, close bracket, open bracket 0.23, 4, close bracket, and I get 30.2 degrees. And that's where I get that answer. So number 14 says you stand on a bike pedal shown on figure 7. Your mass is 65 kilograms. Okay, so my mass is 65 kilograms. If the back paddle makes an angle of 35 degrees, so above the horizontal of the pedal, so what I'm going to do is I'm going to take, it says above the pedal, so I'm going to take my 90-degree angle and I'm going to subtract 35 from that, and so 90 subtract 35 will give me 55, and that's the number I'm going to use. and the pedal is 18 centimeters. Well, I'm going to do that as the radius, okay? From the center of the chain, how much torque would be exerted? So for this one here, what I'm going to do is I'm going to change my formula to mass times gravity times radius, sine, and the angle, okay? So on this one, I'm going to do 65, open bracket, 9.8, close bracket, open bracket, 0.18. Close bracket, open bracket, or better yet, probably don't need a bracket, so I'm going to go back one, I'm going to delete it, and I'm going to do sine, and I'm going to do 55, close bracket, enter. And I get 93.92, 39734, and I made it to 94 newtons. So then the last part that we have here is this talking about finding the net torque. Okay, so I just started another page. This is page 211. And I will do that either later on today or I will do it tomorrow. And then we will go over the sample problems, example problem, and we're going over the practice problems for that. And then we will be ready for Friday's work tomorrow. I hope